probability there, Jordan. And a little subheading under probability. How about, let's say, probability multiplication rule. Probability. Little subheading here, multiplication rule. Let's say you asked for the probability of taking a coin and flipping back-to-back heads. A head and then another head. What would that probability be? Care to speculate? Speculation out there? Peter? Wait, so you're saying every time I flip a coin twice I would get a head? Huh? 1/2. So half the time I get 2 heads? Jacob?
1/4.
1/4? 1 out of 4 times? Evan? Let's say 2/2. 2/2 would be the same as 1. It would happen every time. Well, to figure it out, let's make a little tree diagram. The first flip, I can either get a head or a tail, correct? Let's say I flip the head first. Well, on my second flip, off of that head, I could get either another head or a tail, and off of this tail, I could get a head or a tail. So my total combinations for this would be, I could get a head and a head, which is what we wanted, but I could also get, I guess I don't want a comma there, I just want a head and a head. I could also get a head and a tail, or I could get a tail head, and my fourth possibility is the tail. So how many different outcomes can I have? There's 4. Of those, how many are the head I want? Just 1. So whoever said 1/4 is correct. Now, you don't want to have to draw little diagrams every time you do something like that. So there is a mathematical rule that says this. I don't know why I write this down. It says, let me get it right down to the book because I have to mash it there. If events A and B are independent, just write that down. If events A and B are independent, then the probability, how about that? This is then the probability of getting A then B is their probabilities multiplied together. Their probs multiplied together, which is a lot of words for what it really is. Looking at another instance here. Let's say you're flipping a coin. I'll do my best, George Washington or Abraham Lincoln. It's not bad, is it?
Put hair on.
There's no hair on the coin. And then you spin a spinner. If I asked you the probability of getting a tail, then spinning a 4, how do I find that out without having to do the whole tree diagram? Well, I just look at the probability of each one. As long as they're independent and they're not connected with each other, one doesn't depend on the other one, then you can just take, what's the probability of getting a tail when you flip a coin? 1/2. What's the probability of getting the 4 on the spinner? 1/4. So the probability of both of those happening is those two probabilities multiplied together. It would be 1/8. Got that? Looking at a deck of cards, what would be the probability of getting a jack? A guess we'd have to put the card back in the pile. And then a queen. If you blindly just picked 2 cards, but you'd have to put one back, so what's the probability of getting a jack in the deck of cards? Who's the card charts out there? Well, how many jacks are there? Aren't there 4? There's 4 jacks out of 56 cards. Trust me, this just reduces down to 113. Okay? How many queens are there? 4, so it's the same thing. 456, which reduces down to 113. There's a lot of, you have to put the jack back for this to be true. So the probability of you just taking a deck, drawing the jack out, putting the jack back, and then drawing the queen would be 1 over 13 times 13? 169. Is it going to happen very often? No. The probability of you winning the lottery?
100%. My great.
Well, you can kind of get close to it. I don't know anything about the lottery. But you'd have to do the probability of, what do you have to, how many numbers do you have to draw?
Like,
Huh?
Depends which one you do.
Dude, let's do the big one. If you're going for the big one, isn't there 6 numbers or 5 numbers?
There's 5 and then so there's like 6 I think.
Powerball.
Let's say there's the probability of picking number 1, number 2, number 3, number 4, number 5, and number 6. And then you have to know how many numbers are there? How many digits are there?
So
1 through 60? Let's just say it's 1 through 60, I don't know.
many lines.
Your probability of picking 6 numbers right, well, the probability of, it would be the probabilities of picking each one right. Probability of getting the first one right would be 1 out of 60. Now here's where you have to be careful because they don't put that ball back in, there's only 59 balls left. So the probability of picking the second one right is
Oh, yeah.
1 out of 59. Probability of picking the third one right, there's only 58 balls left, so you get 158. Of the next one right would be 57 choices. What is that? 1, 2, 3, 4. 56, and then 55. Now because I don't want to do that math, I'm going to find a calculator or something. So your probability of winning the lottery is, what is it, 60 times 59 times 58 times 57 times 56 times 55?
Yeah. Oh my God.
According to this, it's 3, oh wait, where'd it go? Can I keep it up to 360459, 360459. Why doesn't it stay up there? 6459, 79200. Is that really right? That seems a little high.
36 billion.
36 billion? 1 in 36 billion? That seems a little high. I must have something not quite right. Maybe there's only 5 numbers, is there?
I thought there was a Powerball or something.
There's
Fireball.
5.
Is there only 5 numbers? And then there's a Powerball, whatever. The gist is, you know, they say somebody's gonna win, it might as well be you, yeah, well, that's true, but you have greater odds of actually, finding $1 million on the street than it is there. The other thing I want you to write down is this, do you have enough room to do this? I need you to draw yourself kind of a nice sized rectangle. I should have probably made you a copy of this, but a lot of times they talk about the probability when you roll, the probability of getting like this. What's the probability of rolling a 7 with 2 dice? And in order to be able to do that, you really have to have a little table there to look at how many different ways there are to make 7 with 2 dice. Because you could have like a 3, a 4, or a 1 and a 6, or whatever it is there. So here's kind of what that looks like. You need to make 6 columns like this. And you need to make 6 rows kind of like this. I'll cut it in half. Cut each half in thirds. Because this kind of shows you the different combinations you can get different numbers with. Let's say going down here is 1 dice. I can roll a 1, a 2, a 3, a 4, a 5, or a 6 on 1 dice. Going this way, I can roll a 1, a 2, a 3, a 4, a 5, or a 6. This gives you all the different combinations you can get when you roll 2 dice. Dice 1, dice 2. So you can get a 1 and a 1. Get a different color here. If you roll 2 1s, where's my mark? Oh, there it is. If you roll 2 1s, what's that total? 2. You can roll a 1 and a 2, that gives you a 3. A 1 and a 3, which adds up to 4. 1 and a 4 is a 5. 1 and a 5 is a 6. 1 and a 6 is a 7. A 2 and a 1 is a 3, and you can kind of see it goes in this pattern like this. Take my word for it. 2 and a 6. 3 and a 1 is a 4. 3 and a 2 is a 5. 6, 7, 8, 9. 4 and a 1 is a 5. 6, 7, 8, 9, 10. 5 and a 1, 6, 7, 8, 10, 11, and 7, 8, 9, 10, 11, 12. When you roll 2 dice, 2 die, 1 die, 2 dice. When you roll 2 dice, how many different possibilities are there? There's 36 different possibilities. Okay, but some of them you get the same number when you do that. So that's why you kind of need the table there. You know, your probability of rolling a 7 was the question. You have to look at how many of these 36s are 7s. 1, 2, 3, 4, 5. 6 different ways to get a 7. 6 out of the 36 are 7. So the probability of rolling a 7 is 1/6. That's your greatest probability when you roll 2 dice. Your probability of rolling a 1, how many 1s do you see up there? 0. 0 out of 36. You will never roll a 1 when you roll 2 dice. What if 1 stands on end? Huh? Then it defies gravity. Probability of a 2? How many 2s do you see in our table?
1
Yeah, just 1/36. You probably don't really want to root for a 2. What about the probability of a 9? How many 9s do you see out of 36? 1, 2, 3, 4. So you have a 1/9 chance. The book will ask you questions like this, so you need to have this in your notes because you don't want to have to draw it every time, and there's really no way to do it without seeing it like that. So make sure you have that there. Take a look at page 460. Look at practice problem letter C. Two number cubes are rolled. What's the probability of rolling a number greater than 4 on each number cube? What's the probability of rolling a number greater than 4 on each number cube? Now that's not this, just so you know. And here's how you'd write that down. The probability of rolling a 4, a number greater than 4, right? So if you ever see something that looks like that, probability of greater than 4. Well, on the first cube, how many numbers are greater than 4? 5 and 6. So 2 out of the 6 are greater than 4. And then what's the probability of rolling a number greater than 4 on the other cube? 2 out of 6. So the probability of those both happening are 1/3 times 1/3, which is 1/9. Don't get that confused with what we just looked at in the book. Let me see if I can find one. Do you see one where it asks about, any questions in there where it talks about rolling two cubes? Maybe not. Maybe not. Yeah. I guess we'll worry about that when it comes up there, so. Alright, your assignment then, children, let's do lesson 68.